This is a compact 50-watt dimmable LED that I designed and built for filmmaking. It has 4 mounting holes on the front, allowing you to connect a variety of accessories such as a softbox or even a lens. The version 2 will also house DMX. It's designed to be easy to make at home, requiring minimum tools. Stick around and I'll show you how you can make one.
The goal of this project is to create a mini stage light like this light here, except at a much more affordable price point. This project will be done in 2 parts. We start out with the LED you see in the intro. Then we add on a lens. The first lens focuses the light down into a single point. The second lens gives us the angle output that we desire. This focus point in the center is very important because once we add our shutters on, that is what enables us to actually sculpt the light. Using the shutters, we're actually able to shape the light. And this will be done in 2D with 1 shutter on each side, so there will be 4 total, not just 2 like seen here. And then finally the DMX module will just bolt in the middle or on the back, I haven't decided yet.
For this project, you do need some specialized tools. You'll need access to a 3D printer, and the prints take about 18 hours total. You'll need access to a soldering iron, and you'll need a Phillips head screwdriver. It's worth noting that often you can get access to a 3D printer through your local library as long as you pay for the filament.
Part 1 of this video will just focus on the LED portion of the build. Let's get started. We're going to start out with 2 3-inch long wires. One should be a minimum of 16 gauge and the other can just be a generic computer wire. This just powers the fan. Now we're going to solder them on to our XT60 connector. We're going to take our 2 smaller wires and solder them onto this voltage reducer board that will power the fan. Once you're done soldering that, you can set this aside for the moment and we're going to grab our bigger voltage booster board. Locate the variable resistor that controls the voltage and desolder it. Next, we need to calculate which variable resistor needs to be put in line to have the brightness go from all the way up to all the way down with 1 turn of the knob. First, we find out the voltage range that our booster covers. Then we desolder the variable resistor and find out that it's a 50K variable resistor. Next, we look at the range that our LED covers. It covers an 8-volt range. Now we divide the value of our original variable resistor by the range that our voltage booster covers. And this will tell us how many kiloohms of resistance we need per volt. Next, we multiply this times the 8-volt range that our LED covers. And this tells us that we need a 11.1 kiloohm variable resistor to cover the entire range. I'm going to use a 10 kiloohm resistor and just have it be not all the way dim at the very bottom end. Now we're going to solder on 2 leads to the voltage booster board. Then we'll solder the original variable resistor to one of the 2 wires, doesn't matter which. Next, we'll connect the other 10K variable resistor to complete the circuit. Connect the XT60 connector we prepared in the previous step, and now we're going to get the voltage booster in approximately the right place. Make sure that the 10K resistor we added in is turned all the way up before you set the maximum value using the blue 50K resistor. Now we're going to disconnect the XT60 connector and feed it through our 3D printed back plate. And then we're just going to super glue it in place and push it in. It has a nice satisfying click sound when it fits in place. We're going to make sure that the air is blowing in the right direction, so it's blowing out the back and not out the front, and then we're going to fit our fan in. It's a pretty snug fit, so you might have to fiddle with it for a little bit. Now we're going to finish off our back plate by reconnecting the power and installing the voltage booster board and the resistors into the housing. I'm just going to super glue the original 50K resistor to the side of the housing for easier adjustment later. I put a little electrical tape over the power wires for the LED so vibrations would not cause it to eventually short out. And then we're going to fish the power wires for the LED through the middle part of the housing and install the heatsink into the housing itself, making sure to align the bottom approximately level. Now it's time to install the front cone. I use a drill to speed it up a little bit here. Next, we're going to super glue in the 1/4 bolts into the side that will be used for the mounting. And I just use a bolt to press it in because it's easier, no super glue in my hands. Now we got to connect the voltage reducer for the fan and then just super glue it on the side of the housing so it stays out of the way. Off camera, I use some needle nose pliers to feed the LED power wires into the output of the voltage booster. And then I just use a bolt to feed in the nut for the bolts that hold the whole thing together. And then tighten down the screws. One thing that I didn't show on camera was after I connected the fan, but before I closed it, I went through and adjusted the current maximum switch on the voltage booster so it wouldn't go above 1.5 milliamps or whatever your LED is rated for. Next, you feed these 1-inch long 1/4 bolts through these twist knobs and then use a bolt to force them in. Lastly, attach this U-shaped bracket which can be used for adjusting the angle of the light. And that's it, you finished the light portion of this project. In part 2 of this project, I'll be showing you how to turn this light into a DMX controlled light and how to add the lens that will give us the control of the shape of the end of the light. A final note for those of you who actually plan to build this, because we're using voltage boosters to power the LED, you can only use a voltage lower than the voltage that's going to the LED. So for this voltage booster, you can use any voltage between 6 volts and 22 volts. 22 being the maximum because that is the minimum voltage that the LED will take before it turns on.